So I did one video on properties of exponents, using exponents to multiply monomials, dividing binomials. In this video, we're going to look at the multiplication of polynomials. So it could be a monomial, like the first one here, times a binomial, meaning two terms. It could be a binomial and a binomial and a trinomial, and so forth. This first one here, we're going to use a basic property called the distributive property of multiplication over addition. So it simply says if you have a sum of two terms, it could be a binomial, multiplied by a single term, monomial. See, you simply multiply what you have outside the parentheses here times the two terms you have inside. So this would be AB plus AC. And that's as far as we can go with that. Okay, they're not really like terms here, so that would be it. Now in the first one, we would have then, using this distributive property, this term then, or monomial, would multiply the first term here, and then we go and multiply the second term. So it'd be just like multiplying monomials, because that's what a polynomial is. It's the sum or difference of monomials. There could be one involved, could be two terms involved, binomial, could be three, a trinomial. And then if it has more than three terms, you just basically call it a polynomial. So I'm going to write this out this way. Say, okay, this is going to be 3x squared, y squared. Could write this in parentheses just to emphasize that this is going to multiply the first term inside the parentheses there, 3x y cubed. And then I'm going to put a minus in front here. That's that minus right here. It carries over. And then this term again multiplies. So I'll put that in parentheses. 2x squared and then this next one would be 2y. And then to complete this, you see if you multiply each one individually. So here, using the rules for monomials, we multiply the coefficients. So 2 times 3, that would be 6. And we have an x squared and an x. So we multiply powers of the same base. We add the exponents. So just bring down the base, in this case x, add the exponents. This is 2. This answer to be a 1. 2 and 1 gives me 3. Okay, then it's y squared and a y cubed. So bring down the base, y. Add the exponents, 2 and 3 gives me 5. And then I'll carry the minus over, and then over here again, monomial times a binomial. Multiply the coefficients, 2 times 2, that's 4. And we have an x for the first one, bring it down, add the exponents. So it's x squared. The other one doesn't have an x, so that's as far as we go. And then a y squared, bring it down, add the exponents. Remember, if it doesn't have an exponent, it's understood to be 1. 1 and 2 is 3. And that's your final answer. Now you can do it mentally also here without writing it out, depending on what your teacher tells you. But you just go, okay, this term multiplies the first term here, so it's 2 times 3 is 6. X squared and x, that's x to the second, x to the first, so add the exponents, x to the third. And then y squared and y to the third. Bring down the base, add the exponents, 2 and 3 is 5. Bring down the minus sign right there. And then again, the next term, 2 times 2 is 4. X squared, this second term doesn't have an x, so just bring down the x squared. And then the y squared and the y multiply, 2 and 1 gives me 3. So minus 4x squared, y to the third. That's your solution. So in this case, in number 1, we're multiplying a monomial times a binomial. Binomial because the second one has two terms. clear this. Okay, this one's a binomial times a binomial. So basically I could do the same thing here and treat this first one as a term, and it multiplies the first term and the second term. So let's set it up this way, and then we can do some shortcuts here. But this would be then, just pretend this is like the first one. This is one term multiplying the binomial, even though it's also a binomial. But let's write it this way: x squared minus 2y squared this multiplies the first term, so this will be 2 x squared. Then bring down the sign, this one here, and then again the same term multiplies the second term. So I write this out: x squared minus 2 y squared times the second term, which is 5y. Okay, so again, all we did was treated this as one term, and we multiply it this way. Here it is. And then, same thing, you multiply the second term. Okay, so now this first one, this is just like the first one, except that here the term's on the right side, but it's the same thing. This is the same thing, same type of problem as number one, except the term is on the right side. But either way, it's going to work. Doesn't matter what order you multiply. 2 times 5 is the same thing as 5 times 2. So all we're doing here is we're going to multiply this from the right side. So it's 2x squared times x squared. Okay, so mentally you can do that. The coefficient here is 1. So 2 times 1 is 2. And then x squared times x squared, bring down the base, add the exponents. 2 and 2 is 4. Okay, now you multiply the next term from the right side. Bring down the sign, minus, and then 2 times 2 is 4. And then we have y squared and x squared. They're different. You don't add the exponents here because it's not the same base. Just bring them down. So this will be y squared, x squared. And then we do the same thing. So this will be a plus 5y, again, multiplies each of the two terms inside the parentheses. So 5y times x squared. The coefficient on the x squared is 1, so 1 times 5, you just bring it down as 5. And then x squared by itself, because the other term doesn't have an x, so don't mess with the exponents. And bring down the y. Okay, now the 5y multiplies the next term this way, so bring down the sign, minus 5 times 2, that's 10. And then here we have a y squared and a y. This one has an exponent of 1, so it's y. Bring down the base, 2 and 1 is 3. And then all you do now is to see if there's any terms that are the same. In other words, here we have a 2x to the 4th. If we had another x to the 4th by itself, then we could add those up. But that's it. We have a minus 4y squared x squared. Do we have another term with an x squared y squared? No, we have an x squared y. But this is different than this one. We have a y to the 3rd, one term with y to the 3rd by itself, and that's it. So don't add terms if they're not the same. They have to be exactly the same. So in other words, if you have a 2x y plus a 5xy term, that's the same. Coefficients, you just add them up, 7xy. But if you have a 2xy plus y, Can't add them up. You just leave it that way. Just like A plus B is A plus B, because they're different. A is different than B. You have A plus A, that's 2A. Double check your answers. Now, another way we could do this is this kind of thing. We could also do it this way, especially when you have two binomials. X squared minus 2y squared and 2x squared. This works nice if you're multiplying binomials. I guess it could also work with other ones, but this is the more convenient. Got a binomial and a trinomial. You can do something like this also, but you can't go wrong. You can't go wrong with the distributive property. So here's what we can do. Just like multiplying regular numbers. So we go this way. Let's just multiply everything. 5y this way. This way. So 5y times minus 2y to the third. That's a minus 10. This is y to the second here. Okay, so x squared minus 2y squared times 5x squared plus 5y. So we'd go 5y times minus 2y squared, so 5 times minus 2 is minus 10. Bring down the y, the base. The exponents are 1 and 2, so this would be 3. That's 10y to the third. And then this 5y multiplies the x squared over here. So that would give me a 5x squared y. And we go the other way. With the 2x squared, multiply this way. So 2x squared times a minus 2y squared. That'll give me a minus 4. 2 times minus 2, that's minus 4. X squared times y squared is x squared y squared. So that's a minus 4 x squared y squared. If you see that you have something I like here, put it under there. Like if this had been a minus 4x squared y, then I'd put it under this one. If I'd gotten a minus 510y cubed, I'd put it under this one. But they're all different, so separate them. And then finally you go 2x squared times x squared. That's 2. Coefficient of the x squared, remember, is 1. X to the fourth. And then, like I said, you combine if there's anything to combine. But here, there's nothing that's similar. So we just leave it 2x to the fourth. Is what I got over here. Minus 4x squared y squared. Notice, doesn't matter the order here. It could be x squared y squared or y squared x squared. Still the same term. Order doesn't matter. Commutative property of multiplication. And then have 5x squared y. There's the 5x squared y over here. Minus 10y to the third. Minus 10y to the third over here. So yeah, I get the same answer. Let's clear this. So this one again, you could do this. We did already one like this. You could go x times x, x times y, and then minus y times x, minus y times y. Or if I set it up this way, kind of like regular multiplication of numbers, I could do it this way. So go this way. The y multiplies both of those terms, and then the x multiplies both of those terms. Doesn't matter where you start, on top or the bottom. So y times minus y is minus y to the second. The exponent is 1 and 1. Remember, if the coefficient is not there, it's understood to be a 1. If there's no visible exponent, it's understood to be a 1. Okay, now y times x is xy. Okay, so I have this minus right here. Y times minus y is minus y squared. Y times x is xy. Now we multiply this way with the x. X times minus y, include the sign there, x minus y is a minus xy. then x times x is x squared. Now notice I put xy and xy under together because those are like terms. The coefficient here is a 1. Coefficient here is understood to be a -1. Those cancel out. So what does this give me then? I've left an x squared minus y squared. Now I put some of these problems, especially the last two, on purpose here because coming up later on for you is factoring. So when I multiplied x minus y times x plus y, I got x squared minus y squared. Suppose it's the other way around, and the instructor tells you take x squared minus y squared and factor it. Just if I give you, say, 6, and said express 6 as a product of two numbers. 2 times 3 would be 6. Or you could say 6 times 1 is 6. So you have the same sort of thing in algebra. You get something like x squared minus y squared, a difference of 2 squares. So keep that in mind, difference of 2 squares. What does this factor into? What two binomials multiply to give you x squared minus y squared? Well, right here. X minus y, x plus y. Okay, this one, again, you could do it the same way. I could, if I use it distributive property, the x minus y will multiply the x squared, will multiply the xy, will multiply the y squared. You could do it that way, just like the one I did earlier. Or you can go the other way and say, okay, I'm going to multiply each of these by x. So let's do that first. X times x squared, x times xy, x times y squared. So let's do it that way. So it's like multiplying a monomial into a polynomial. So x times x squared is x cubed. X times xy is a plus, and here you want to include the sign, whether it's a positive or a negative. So this would give me x squared y, then x times y squared, I should say x times y squared is xy squared. Okay, now we do the same thing with the second term. Include the sign with it. So minus y times x squared minus y times x squared is a minus y x squared. And then minus y times xy is a minus x, and then y times y is y squared, so this is y squared. And then minus y times y squared, bring down, it's a minus, so minus y times y squared is y cubed. This one right here is a y. Yeah, this is a y. So I have x squared y, positive, minus y x squared. These are the same. Okay, different order, but it's the same thing. Y and x squared. You have a y and an x squared. One's positive and one's negative, so these cancel out. And then here, x y squared, positive, and then a minus x squared y squared. These cancel out. So I'm left with x cubed minus y cubed. So the answer to this one, when you multiply it out, is x cubed minus y cubed. So just again, another reminder that you're going to be multiplying polynomials out, and then the opposite operation is to factor. If I multiply x minus y times this trinomial, we get x cubed minus y cubed. Now, the question later on for you is going to be, if you're given x cubed minus y cubed, what does this factor into? So this is actually a formula. It's giving you the difference of two cubes will give you this product right here. Just like in the other one, the difference of squares. x squared minus y squared was x minus y, x plus y. So multiplication of polynomials. Thanks for watching. See you next time.